Hello and welcome to my session on real-world AI and automation for business. I'm Jon Silver. I'm R&D Director of JFDI Consulting. I've been knocking around the industry for quite some time, and I'm a lifelong engineer, inventor, and maker. I've always been problem-solving using bits of technology, and it doesn't really matter to me what kind of technology that is. The solution is the important thing. I brought with me to JFDI an ethical approach to consulting, which is shared by my co-director and co-founder, Joel Jeffrey, and we're passionate supporters of the UN global goals because we think that the only way we can solve the bigger problems facing the planet is together and using technology. At JFDI, we like big, bold messages and very, very bright colors. We think that you can automate everything. We're technology agnostic. We really don't care what technology we use as long as it's appropriate for solving the problem. We largely use custom code, application software, and collaboration platforms, some hardware, cloud computing, and even microcontrollers, electronics, and 3D printing. Automation relies on data and making sense of it. So it's just really important that whatever you need to automate, you collect the right data and process it in the right way. So what we'll cover in this session is all of these things, and hopefully you'll end up with a clearer idea of what's possible by automation, how much it costs, what it involves, some of the risks and dangers, but also the rewards. So how to understand automation and avoid the confusion? The confusion is often caused by all of the industry buzzwords because there's a lot of industry buzzwords. I've represented them here in the form of a hedgehog for no reason other than because I like hedgehogs. But it really serves to demonstrate one thing, and that is that often all of these buzzwords get mixed in together in a blurred, jumbled mess of concepts. There's AI and machine learning and comms technologies mixed in with general automation stuff and made up terms. And the industry doesn't really separate these very well, and this causes an enormous amount of confusion about what automation actually is. So these are my selected automation buzzwords, the ones that matter most. These are the ones I'm going to go through in this presentation. Actually, I tell a lie. I won't really be going into the last one, Internet of Things, because by the time you're connecting software to the physical world, that deserves an entire presentation by itself. But it's something we do a lot at JFDI, so let us know if you'd like a future presentation on IoT. So let's compare human versus machine. Humans are good at abstract thinking. We can understand and derive meaning from massive complexity and extrapolate from a few known facts to make judgments or predictions. We can simplify complexity using abstract thought, but we're very slow and vulnerable to tedium. We're also prone to making errors, especially when bored or tired. We need feeding as well, and not just food. By the time you employ somebody, you're supporting their entire family, and that's quite a big responsibility. So you need to think very carefully as to whether you need another person or whether you need just to make your existing people more efficient. Machines do repetitive tasks quickly and accurately. They don't get tired or bored, and they don't have feelings. With AI techniques, they can have both high throughput and accurate scoring or classification of patterns or context. And that's a very different thing from abstract thinking, but it can appear like it's the same thing. People are very flexible. Machines can only follow their programming, even if that programming incorporates learning and adaptation. The other thing is machines are made by humans, and therefore they're prone to design mistakes and bugs, but they do have very low running costs. So how to automate the process? Well, first we have to understand the process. This is actually more complex than you might think. Surely business people understand their business processes. But actually, the majority of business people don't really understand their business processes at all. In middle management, hardly anyone actually sees processes, thinks in processes, and understands the processes that the company operates to do what it does. Even at board level, people often don't have a great handle on it. So we have to go in and understand the business processes intimately from those who actually know the processes. And this requires skills like knowledge elicitation, an entire discipline in itself. And we can't just make new automated versions of old procedures because just because you've always done it this way doesn't mean it's right. It may be wrong now and even more wrong in the future. Next, we have to find the bottlenecks, the pinch points, the places where data doesn't flow well or stops flowing around the organization completely. They're the bits that cause your customers anger and your staff frustration. So your company really needs to get a handle on these and nip them in the bud. And automation is the best way to remove bottlenecks from processes. You need to identify the smart bits. These are the bits where human qualities are invaluable, like abstract thinking, judging a situation which may have grey areas, taking the kinds of choices that require some sort of moral judgment. Those are the bits where you need to integrate humans into the process, even the automated process. And that means that those bits may in turn become bottlenecks unless you take steps to ensure that that doesn't happen. You should solve the easy wins first. You look for these things because they're the bits that require the least effort and yield the biggest rewards, like replacing long copy and paste operations. The tiniest bits of code, the tiniest automations can actually deliver the biggest wins for your least investment to the organization and to your people. Finally, well, you should engage experts. And I would say this, wouldn't I? Because I guess I'm one of those experts. But this is a really important thing. If you've got a budget for automating processes, don't squander it on experiments. Don't try and fail at coming up with the best way of spending your budget. Ask somebody who's done it before, lots and lots of times, in lots and lots of situations, with loads of different technologies and with loads of different sorts of processes across many industries. It's really important to realize that in automation, in any system you create using technology, there are no silver bullets. You should ignore vendors and fanboys and fangirls and fan people because ultimately they are all focused on tools, not solutions. You need to focus on the problem and work out the most appropriate solution. There is no single tool on the market that can provide all of the answers to your automation needs. It just doesn't work like that, and it never will. We use such a diverse range of tools to create and fabricate solutions for a very wide range of problems. And all the business problems we come across are completely unique and beautiful snowflakes, just like the businesses they come from. And that means that we have to be very, very solution focused. We can't just map one-to-one a person to a machine. People are supremely flexible and do all sorts of things in their working lives, switching context with ease. Software tends to be used to do one thing over and over again, so it's really important not to just think that you can map people to machines. Also, automation, like any system, is not a one-shot process. We'll see why in a little while, but it's all down to the chaotic and complex nature of change and the causes of change. So we need continuous improvement. We need to look regularly at the process and judge how well the system that we've got fits that process. And of course, be prepared for the consequences if it's found not to fit very well anymore. So earlier I explained that processes have lots of hidden bits, and it's important to realize that what we automate is always processes. There's nothing else to automate, really. Processes involve data and decisions and branching and processing with complex interactions between them. All of this knowledge in organizations is mostly hidden in people's heads. And replacing brains is very, very hard, as we've seen, especially when you're replacing a human with a machine. Machines don't think like humans. Humans don't think like machines. so you can't just map one-to-one. So at this point, it's really important to tear apart this thing between AI, machine learning, and automation. And it's important to realize, as part of that, that not all automation is AI. In fact, most of it isn't. But the good news is, all automation is magic. So what do I mean by magic? To the user of a piece of technology, all automation is magic. It's magic when the lights come on automatically when you enter a room and go off after a few minutes after you've left. To someone who has to spend hours gathering firewood and kindling and tinder just to make fire to keep warm and boil some water to have a hot drink or just wash. Anything that automates all of that so that you can just boil water at the flick of a switch is pure magic. If a large part of your working day involves copying and pasting data from one system to another, the one-click automation that does an entire operation for you is pure magic. Okay, so what I really mean by magic is high utility value for little opportunity cost. It doesn't have to involve any kind of intelligence, but things can seem intelligent just by matching values within a tolerance, which has been done for decades by things like soundex codes to find records that sound similar to a search term. So that's nothing new. It's just fuzzy logic, and we've become accustomed to that as the norm. To the user, it seems intelligent, but it's not AI. Much AI is actually machine learning, which is advanced computational algorithms and statistics. That's not to denigrate what machine learning is, but terms like machine learning and AI are often used interchangeably, and it's really important to realize the difference between the two. AI, true AI, things like neural networks, are still expensive and still relatively inaccessible. So does it matter whether it's AI or just general automation? No. The point I'm trying to make here is that to the user, everything automated may as well be AI. It's just magic. It makes their jobs easier and can make their lives better. It gives them superpowers. It makes their working lives better, and that's what we should be trying to do for our people. So at this point, I'm going to introduce a gnarly concept, API, or Application Programming Interface. APIs are just fundamental to automation of all kinds. An API is just a controlled way of talking to a computer system from outside, and it allows you to query or interrogate that system or inject data into that system in a controlled way. The most common type of these is a REST API, which is where the transport and encryption protocols are the same ones used by the web. APIs can be private or public, but even the public ones have some sort of security, even if it's free to register. Generally, APIs can be seen as packaged functionality, a black box of stuff that somebody else has created that you can call to make use of those services. If you want some current weather information or some travel information, something like that, don't code it yourself. Don't expend the enormous effort to create those information services yourself. Reuse somebody else's through an API. So here's some API examples. This is just a few of the things that you can do with APIs. There are computer vision APIs where you can just fire an image at it and have the underlying AI describe to you what's in the photo in words. Pull out the visual context, and that's really useful. Contextualizing anything abstract is useful. The same is true of applied AI and machine learning, where you're always trying to get some sort of verdict, some sort of judgment or pattern being recognized, or some context drawn out of something abstract. There are things like APIs for talking to accounting and ERM and CRM systems, weather APIs for getting weather data. You can just get weather forecasts or current weather observations, past weather data, that sort of thing. There's image processing ones. So you can take an image and crop it, rotate it, resize it, and maybe process the image data in some way to change the brightness, convert it to black and white or whatever. And the most impressive thing is that you can have all of these things done in the background by just a machine talking to another machine through an API. And that's the most useful thing that you can have a machine do generally, talking to another machine. And they do it very, very fast. Mapping and geocoding is extraordinarily useful as well. We created a route optimizer system, which is actually based upon the Google mapping APIs. And that's the interesting thing about APIs, when you build stuff out of them, because until then, they're just building blocks. So, for example, just with APIs that are available from Google, you can actually take spoken words and turn them into text, translate that text into another language, have that translated text turned back into speech, and then play that back. So you can have an entire end-to-end language translation feature built into a system just by using APIs and tying them together. And all the clever stuff's done for you. What's not to like? Of course, APIs don't exist in isolation. They're just building blocks. You have to hook them together with something, and the something is generically called workflow. Workflows work with APIs to take the information that you get from one and take it to the next one. And in this way, they can automate data retrieval and entry. They move and transform data between systems. They run the processes that transform, process, or store the data between stages. They get human input or approval. So I said earlier that you can't always cut a human out of a process, that you often have to include them. And the way we do that is by having the workflow send some data to a human, pause for some sort of response, maybe their approval or adding additional data, and then take that data and move it to the next stage. And this is a really important thing. Escalate when nothing happens. So, for example, a machine's offline. Oh dear, if a machine's offline and it's a vital part of a process, maybe a vital API provided by someone else. So something's got to be done about that. Probably raising an alert with the appropriate system admins. But also, if a human's gone on holiday, quit their job, or just popped out of the office, had a bad lunchtime under a bus, and not returned, the process can't just be allowed to stop. So, workflows have to have all of this logic built in. Workflow can actually be custom code, bespoke developed software, but it can also employ low-code or no-code rules processing. And this is a really important concept. Custom code is a very expensive option, and low-code or no-code is seen as something that a power user can go and change when small adjustments are needed. So, some workflow tools. I've included our own Bob at the top. Bob is a workflow engine for real-time and time series data with a no-code rules engine that can perform complex logic. Bob was created in response to a hole in the market that we saw, particularly in the realm of smart buildings, but it can be used in lots of other ways as well, anywhere needing the ability to take in streams of data very rapidly, process them, and come up with outcomes within milliseconds, so people don't even notice a delay. And all of that's very easily custom reconfigurable and with no programming. There's Microsoft Power Automate, one of our favorite workflow technologies, and IBM's Node-RED, which we've also used extensively. Tools like Nintex are mainly focused on what happens inside the enterprise, whereas general-purpose workflow engines like Zapier work on plugins which allow you to link outputs from one cloud service to another's input. PowerShell. We use PowerShell an enormous amount. It's basically a shell scripting language, but it's amazingly powerful and allows us to do incredible automations, and it's part of the custom code that we use to make automation happen. Sometimes there are no APIs for talking to a particular system. The only way in is through the screens that humans use to talk to that system. And in that case, we need RPA, Robotic Process Automation. It's a way of putting a computer in front of the same screens that are used by humans, but having all of the keystrokes and mouse clicks automated. They can also do intelligent OCR, automatically taking in images of documents, translating the symbols on the page into text, and then finding patterns in the text, pulling out a date or a number from that text, because it will be in a particular place or surrounded by some structural text, which is predictable. So you can scrape data from screens and web pages and paper documents, and you can record and template user actions as well. So when you're designing an RPA robot, you can take a user, sit them down at the screen that they would normally use, and have them perform the actions for a particular task, and then record those actions. Unfortunately, that doesn't give you an automated process. What it gives you is the skeleton of the human interactions that need to be automated. You need to put in all sorts of branching logic to cope with what happens if the back-end server's down, or there is an error message, or what happens if there's some invalid data. So RPA isn't as easy as it can seem, and it's sort of a last resort when you're using legacy systems with no APIs. But as the basis of one stage in a larger process, RPA is a seductive technology. The vendors and fans would have you use it everywhere, and that would be a massive mistake. So some examples of RPA tools. Well, the top one, Microsoft Power Automate UI flows. These are really new and interesting and exciting because they're provided by a major player, Microsoft, and that's quite an interesting entry into the RPA market. Things like UiPath and Blue Prism, they're currently the market leaders, and a lot of organizations are using these with great success. Win Automation, that's been around for like 20 years, I think, and it started as just a little macro tool for automating a few keystrokes in tedious, repetitive operations in Windows. But it's grown into something that's a full-blown RPA system. At the bottom, we've got custom code, because of course we can write custom code to do any of this stuff. Sometimes that's an appropriate thing to do. So earlier, we talked a little bit about machine learning. But what is machine learning? How do we make a machine learn? And what can we teach it? Teaching a machine involves feeding it some data, along with contextual data it can use to spot patterns created by external effects. All of that data forms the data set from which we create a machine learning model. For example, if you want to know how the usage of a system changes with the weather, then you collect the system usage data alongside the contemporary weather observation data. Next, you have to select an algorithm. And there are lots of algorithms to choose from in machine learning, and a lot of these are very confusing, very technical. But they all boil down to just three types: supervised learning, unsupervised learning, and reinforcement learning. Supervised is generally used to map input data to some desired outputs. Unsupervised is great for grouping or clustering data, and reinforcement learning trains the machine to make specific decisions, training itself through trial and error. Then we have to build the model. It's useful to split the data set at this point and use only half of the data to train the model. Then we have the other half of the data set, which has had nothing to do with building the model, to test the effectiveness or accuracy of the model. If you use all of your data building the model, you end up with no data to test it on. And if you use the same data that you train the model with to test the model, then of course it will always work. So you need to give the model some fresh data for testing. Like any system, we can improve it iteratively. Once we've got a model, you can test it using known data, compare its results to competing models, or the results of human processing. A lot of this is done in weather forecasting, where historical data effectively gives you the ability to see the future. So if you feed in your observation data for the past month and try to forecast the weather for yesterday, you'll be able to see instantly how successful the model was. And then the final stage is we take the model and make it part of our workflow. We ingest data and feed it into the model, then we take actions based upon what the model sees. So the model might pull out context from a set of data, or it might classify that data somehow. And so generally, machine learning provides some sort of decision support for either workflows or RPA. So here's some machine learning examples. We could interpret sensor data patterns. We've used this when we've got a complex series of data coming from a sensor that we're developing, and we have to interpret what that sensor is seeing as representing a particular situation. What you can do is create the data set along with an authoritative human decision about what the data from each operation should represent. For example, we had a doorway sensor to count people leaving or entering a room, so it needed to know which way people are going through a doorway. So with a little handheld wireless button, a tester could tell the computer which way we were actually walking. It would then capture the data, and then we were able to take all of these different readings, some of which are wildly different, but all of which conform to some sort of rough pattern. And we were able to come up with a machine learning model that would correctly interpret the patterns of data as whether somebody was entering or leaving a room. Face recognition. This is being widely used, quite controversially in some places. We can either detect faces, that is, recognize the mere fact that there are some faces in a photo. This is quite an easy task. Or we can actually recognize the identity of the people the faces belong to, which requires much more processing power, but can still be done accurately and astoundingly quickly with only modest hardware. We can describe photo contents, which is a kind of computer vision. This is very, very useful. We use this for analyzing our CCTV, for recognizing people and vehicles. For example, a person in a frame taken from the CCTV cameras at a time when there shouldn't be people there, and there's no identified presence. You can forecast weather using machine learning models, as I said earlier, and you can predict machine failure. This is one of the most interesting, useful things. Every component, every machine has a mean time between failure, and that's quite an interesting statistical number. It says how long you can use that component or machine without expecting it to break down. But by taking in telemetry from the machine or some sensors, you can often have a much better idea, much more accurate, of when that machine's going to fail. And of course, you do this by feeding in the data to an ML model. It will detect patterns that led to failure or normal function, allowing you to spot these patterns in future data before breakdown occurs. And this enables you to schedule machine maintenance in order to prevent breakdown. Why? Because breakdowns are really expensive. They generally require some sort of recovery and repair because damage causes more damage, and so preventing a machine failure is generally a much better option than allowing the machine to fail. So let's look at some everyday applications of machine learning. These are just some of the ways in which machine learning is used currently in many different industries. Some of them are more controversial than others. For example, enhanced candidate selection, but they can be really good ways of enabling people to do a better selection job or to recognize patterns when they need to. So, for example, getting alerts of good or bad news. I don't just mean looking at the news and doing sentiment analysis or something like that. It can actually mean, for example, looking at CCTV and judging whether or not there's something bad, like a fire. It may spot an occasional fire where there is none, but as long as alerts are forwarded to a human who can apply their judgment before calling the fire brigade, then it's better probably than having somebody watch CCTV 24/7, because they'll fall asleep, they'll get bored, they'll do a crossword, they'll do anything else except their job, and ultimately they won't do a very good job of watching CCTV because people just don't. Detecting customer activity patterns is something the banks do. They'll block your card if their systems see unusual activity. These decisions need to happen fast, so there's no human involved, even though humans might make better considered decisions. Blocking the transaction is seen as a minor inconvenience that'll happen seldom enough to not annoy cardholders too much. Unfortunately, autonomous systems can be dangerous. Misidentification and misclassification are possible. Sensors can fail, or their data can be misinterpreted. Audit trails are essential because whenever a machine is doing something by itself, we need to know how it got to a particular outcome. The best action, as I've often said, is refer to human, but not always. And sometimes that's just too slow an option. Plus, humans are fallible. So while I was finding content for this presentation, I came across this example of when algorithms go bad. And I just wanted to share this with you. I went to Adobe Stock Photos to search for pictures of people looking frustrated. So I searched for the word incensed, and I got this, lots of pictures of joss sticks. So here's how I think their algorithm works. It looks up the synonyms for your search terms, then it searches for sound-alikes for those synonyms, and so exasperated, incensed, incense. Lots of pictures of joss sticks here, but very few of anyone looking exasperated, except me. Unfortunately, sometimes automation failure results in more serious consequences. An Uber autonomous car hit and killed a lady called Elaine Hertzberg on March the 18th, 2018, as she crossed the road pushing her bicycle. The LiDAR system may have failed to see her. The car's systems may have misinterpreted the inputs coming from the LiDAR system. In any case, the car failed to slow down or stop, and the lady and her bike were hit, and unfortunately, she died. Anyone of a sensitive disposition should probably look away at this point. This is the moment of the accident, and the picture on the left is the lady who was meant to be keeping watch over this unproven autonomous vehicle, this deadly piece of technology as it navigated around the streets. But instead of watching what the car was doing, she was streaming an episode of The Voice to her phone on her lap. So she was looking down for most of the time that evening, and she failed to see Elaine Hertzberg crossing the road and didn't intervene. So this is a case of human operator failure, isn't it? Of course, this is not the only human failure here. The systems were designed by humans, and they were programmed by humans. There's multiple human failure going on in this accident. The people who sanctioned a test of an unproven piece of autonomous technology on public roads at high speed, they were at fault as well. So unfortunately, automation failure is always human failure. Ultimately, I suppose, Elaine Hertzberg had some role in this as well. She failed to see the car hurtling towards her. But that's victim blame and really not cool. So there's some other dangers in automation systems, and these are not unique to automation projects at all. They're general problems with all systems. Generally, when we create systems, we change things. And when we change things, we breed more changes. And you can't predict what those consequential changes are. So by the second generation of consequential changes, all your guesses will be wrong. So you build software to fit a process, and it may change the process. If not, which is unusual, then processes still evolve anyway. People change processes, markets change processes, legislation and regulation, they change processes too. Technology can change processes. Just putting a water cooler down the corridor can change people's behavior enough to change a process. So all of this change is chaotic, and change management is a profession precisely because of this. So one of the biggest dangers of any computer system is that deployed software is, at best, a time capsule like this. Or at worst, it's a ticking time bomb. It's frozen in time whilst the world moves on. Deployed software doesn't keep up with the evolution of the process it automates, but it also doesn't keep up with things like bug fixes and security patches. And those problems are not just in the software itself as it was written, they're in the component libraries that we use to build that software in the first place, and in the libraries that we use to build those. In fact, Every piece of software ever written has a massive dependency tree of building blocks behind it. And what happens is that those libraries move on. They get patched up with bug fixes and security patches, but those changes never get rolled into the deployed software. Deployed software is a time capsule, and that's a real danger. Deployed software becomes more and more of a liability as time goes on. It may even lose compatibility with the current operating system version. So one day the operating system gets upgraded and the software stops working. Of course, you can roll in updates. You can find all of the updated libraries and you can get those compiled into a new version of your software and then test and redeploy your new version, and all the problems magically go away, hopefully. But unfortunately, that rarely happens because once deployed, custom software is rarely updated whether or not processes have changed. And also, reanalysis is advisable or even required before any maintenance programming is done to see if there are any process changes. So it's expensive, but whenever you're creating some custom software, you should always put in place a review process so that you're regularly looking at whether that software needs changing. Otherwise, all you've got is a ticking time bomb. So, one of the other systems management problems that occurs in companies is the lack of inventory. If you ask the majority of companies this question, their answer is this. They have no definitive list of what software they've got deployed, what it does for the business, what process or version of the process it automates. The only records generally come from accounts because they know what they've spent money on, but they don't necessarily have any record of what that software actually does for the business, no matter how crucial or valuable those tasks are. That may have all been in someone's head once upon a time. It may be in some dry audit report that's filed somewhere, but they don't have a central list of what software does what. Custom software is developed and then forgotten except by those who use it day to day. And forgotten software is more and more of a risk to the business the older it gets because of all the unmaintained deployed software problems that I mentioned in the last slide. And because if you don't know what you've got and what it's doing, then you attach no value to it or what it does. So how much does this all cost? It's true to say that most businesses have absolutely no idea how much automation projects will cost. And this is a problem because it might stop some businesses actually using automation because it might be too expensive and they don't know. And it might mean that others think they can do it on the cheap. And of course, that will end up in failure or disaster, or just not being able to do it properly and wasting time and money. So it's really important to get some idea of cost. How do we find out? Consult someone who does it for a living, I guess. So here's a direct comparison between automation and employment. We know that humans have constant overhead. You need to keep the lights on. You need to keep them fed. You need to keep their families in the manner to which they've become accustomed. You've got pensions, payroll, tax, and all of those other costs. UK full-time wages in 2019, according to the ONS, minimum wage almost $16,000 a year full-time, and the average salary full-time $35,000 per year. So taking on an extra person will cost between $16,000 and $35,000 every year, plus all of those other employment costs. Software takes an initial investment and then has low running costs. And we're talking really low running costs. I mean, even the most expensive systems that we've created for clients cost them about £1,000 to £1,500 a year to keep running. But there's an initial investment. How big is that initial investment? The idea is that £16,000 to £35,000 well spent buys you software that just keeps on working for years and years and years, does a consistent job repeatedly and reliably. So why automate? Because for a while there, it seemed like a really risky kind of business, didn't it? Because we get bigger profits, bigger throughput. So for the same investment, you get more revenue. Hopefully that nice big blue area keeps on growing and your costs and overheads remain roughly the same. What you shouldn't do is plan to make anyone redundant through automation. Instead, aim to make the working lives of your people better. So what are the other business benefits of automation? Well, for a start, you can save energy and money and resources, which is a really good reason to do it. You can support your sustainability policy, reduce consumption, but also, and this is the most important benefit of automation, you can stop this. You reduce staff stress and you prevent burnout. With automation, you can give your staff superpowers, able to process more transactions quicker and more accurately than ever before, and with less tedium and fatigue. You can make them managers of a process, not processors of data, because people are terrible processors of data. Every day they can feel they've done a better job, feel more fulfilled, and that will help them, and it'll help you, because after all, a company is a company of people all working together towards a common goal. So give them the tools they need. And those tools are generally these days automation tools. So let's have a look at some of the client projects we've done at JFDI. Some of the real-world automation projects. AutoTag extracts document context through AI and machine learning and heuristics. So the idea is you take a document like this, and what you actually want is this. Not the unstructured text, but what the document's actually about. The important points, the salient points, the meaning, the keywords. Of course, you can add this yourself, but people hate adding metadata and are really, really bad at it. They take shortcuts and they do a terrible job. So AutoTag actually creates document metadata tags, which allow much more fine-grained and structured searching. So it enables research. One of our clients have an enormous corpus of historical documents, which we made much more useful for them. They can actually sort of mine for gold in those documents by being able to search for it using more than just free text, adding value to documents. So this was approximately a £50,000 project cost, and it costs about £1,000 a year to run. Autocrop turns disparate photos into standardized headshots. Our client has thousands of users who each provide their own profile photo. These photos are used on the intranet in many different sizes and need cropping to fit. Sometimes they're photos that people have taken themselves, or they're taken like this one, because the photographer thought it was better composition with the subject standing off to the side. And if you try and apply a standard algorithmic approach to cropping this photo, you'll end up with just half her hair and no face. And that just won't do. People get terribly upset about things like that. And it's an ongoing job creating crops of these photos, because there's new people starting all the time, people change their photos all the time. So the idea was that instead of getting some poor intern to sit and crop these manually twice a year, we should get an AI to do it and get an intern to manage the process. So we created this thing. It was about a £10,000 project cost, and it costs about £1,000 a year to keep running. And it produces this sort of standardized headshot time after time and replaces the background as well. Offsets are no problem, and it produces several crops of each photo for different purposes. The vast majority are done entirely automatically, with maybe only one or two needing manual intervention. Thousands of hours saved. So how does it do it? A computer vision algorithm locates the face in the photo, gives us a rectangle, which we expand a bit in a standard algorithmic way, and then crop. Auto text. This is another one for adding value to documents. A client generates thousands of photos of documents every month and needed the text added. You can store an image alongside text in PDF documents. So AutoText does exactly that by running each through an OCR process. So it makes them searchable, and it's rapid, automatic, and accurate. Once again, it saves thousands of hours of people's time. It's about a £3,000 project cost, and it costs about £30 a month to run. So at JFDI, we like to automate our own processes, and we call that eating our own dog food, or dog fooding. So we've created systems to reduce our manual workload. We don't have many admins. It's just 10 people who are very technical. So we get commercial data from suppliers like Amazon, and we import those using PowerShell to Xero, our account system. And we do the same with financials from PayPal and Stripe. And that means there's a huge amount less manual slog to get that data into Xero. We get lots of things done for us, including exchange rate conversion and that sort of thing. Vastly reduces the amount of typing, retyping, copy and pasting, looking things up and manually importing. We also generate some web pages from databases via scripting. So we take text and graphics and create WordPress pages. Well, actually, MySQL records. But the ultimate automator is Bob. This is the workflow engine I mentioned earlier for real-time and time series data. So it's very, very good for doing all sorts of smart building stuff, which is what we initially developed it for. So we do all of this stuff. We enumerate human presence. We know who's in the building by lots of different metrics. We've got a silent alarm system through Bob, which surprised the hell out of our cleaners when they first started. Bob does our temperature and climate control. We've got leak alarms and fridge and freezer door and temperature alarms. We monitor our car park for interlopers using machine learning and computer vision. And we have notifications to personal devices, plus intelligent voice announcements and alerts in natural human voices, and automatic reboots of things when they need it. We've got old cameras, for example, and sometimes they freeze up, and Bob can detect this and reboot them. Lastly, toilet occupancy and pleasantness. Tells us when the toilet seat's been left up, and some gas detection and status lights to indicate whether the toilet is currently suitable for use. So if you have been, thank you for listening. This is me, and you can use this QR code to get to my LinkedIn profile, and you can email me at that email address. It's been a pleasure delivering this presentation for you, and I hope you've enjoyed it and learned something. Thank you very much. I'll look forward to taking any questions you have.